Hi, class. This is Mrs. Marshall. And hello to those of you who are not in my class. But I am here today to teach you Unit 2's Day 1 notes on polynomials. Part 1, standard form. So the standard form of a polynomial of degree n is this. Make sure you also pause the video as I unveil the notes so that you can write it down. So the standard form is what's in the blue box, a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, which is just technically saying x to the n power is the highest exponent, and that goes first. And then x to the n minus 1 is the next highest because it's 1 minus 1, so lower. And then all the way down to x to the first power and x to the 0 power, which technically is just a sub 0 because anything to the zero power is 1, and 1 times anything is just that thing. So that's all that is. That's a fancy way of showing you're putting the terms in order from largest exponent to the smallest exponent. All right, so now there's a couple things you need to know about this. Thing 1 is where n is a non-negative integer. It cannot be negative and it has to be an integer. And just to refresh your memory, an integer is nothing but a whole number. A sub 0, a sub 1, a sub 2, all the way up to a sub n are the coefficients. So that's literally just the numbers in front, a sub n minus 1. All of these are just the coefficients. Even a sub 0 is the coefficient, but it's the coefficient of x to the 0 power. A sub 0 is the constant coefficient. A sub n is the leading coefficient, and that should have a t on it. A sub n to the x, a sub n times x to the n is the leading term, so that's just the highest, the one with the highest exponent is first, and a sub n cannot equal 0. Examples. Identify if the following are polynomials, and if so, state the degree and leading coefficient. If not, explain. So let's identify the things that we have to, identify. We have to identify if it's a polynomial, yes or no. And then we have to state the degree, state the leading coefficient, and if it's not a polynomial, we got to explain. Example, h of x equals x to the 4th minus 1/4 x squared plus 3. All right, so let's figure out if it's a polynomial. The exponent here is a 4. The exponent here is a 2. Let's see, are those exponents non-negative? Yes. Are those exponents integers? Yes. So guess what? Yes, this is a polynomial. Yes. And we need to now tell the degree. So the degree is 4 because that's your highest exponent. And the leading coefficient, I'm going to abbreviate that, is 1. Why is it 1? Because there's nothing in front. And nothing in front does not mean 0. Nothing in front means 1. Let's do another example. Example number 2. Okay, wait a minute. I do not see a variable at all. That's because the variable is not there. It's an understood x to the 0 power. And since x to the 0 power technically has a non-negative integer exponent, you're good to go. So this, yes, is a polynomial again. The degree is 0, and the leading coefficient is the number square root of 5, an integer. Next example, number 3. This one, let's take a look. Look at these exponents. This one doesn't have an exponent on the end. That's a 1. This one is the problem. So this one is a no. That is no. Why? Because you have a negative integer, and negative integers are not allowed. And actually, I'm going to take that back. Not just a negative integer, a negative number, period. It cannot be a negative number. And so, no is the final answer. Graphs of polynomials. All right, so the common graph of a polynomial is 2 things. Odd degrees, and those odd degrees are 1, like you're just thinking about odd numbers. 1, 3, 5. And so that's an exponent. That's an odd exponent. And it creates lines. So a linear line going up or a linear line going down. So when you have an exponent of x to the first power, that is, like if you think of it in terms of an equation, y equals x to the first, the picture of that looks like this. Or if you have x cubed, the picture of that looks like this. They both go in an upward motion from left to right. So that is exactly what your odd degrees overall common graph will look like. It will look like a graph going up from left to right, or negative. If it has a negative in the front of it, it will look like a line, a linear graph going down from left to right. Then you have even. Even examples are x squared, and that's like the basic even example. And x squared looks like a parabola. And so that's what all the other ones will look like too, except for x to the fourth, instead of it being like a solid smooth parabola with one little loop, it'll just be like a more wrinkled parabola with a couple of more loops, but it has the same end behavior. You got to open it up if it's a positive, so it creates parabolas open up, or there will be parabolas opening down if it is a negative function. One thing to note though, all polynomials are continuous, meaning there are no breaks, no holes, so the domain is negative infinity to infinity. So in other words, if I traced this, I do not have to pick up my pen or my Apple Pencil at all to get from one side to the other. Same here. If I trace this, I do not have to lift my pencil off of the tablet. And you do not also have to lift your pencils off of the paper. So it's continuous. So there's no holes, no breaks. So your domain from left to right, as you trace from left to right, is negative infinity to infinity. All right, so graphs of polynomials without a calculator. So the polynomial in behavior. I want you to draw this little chart. Of course, don't put the dots in it. And if you need to, pause the video so that you can draw the dots or draw the actual chart. But the top row is going to say that plus lead coefficient minus lead coefficient. The plus is for positive, the minus is for negative. And then the side is going to say even degree and odd degree. All right, so now we got to figure out what these mean. So when you have an even degree and it's a positive and you approach infinity, well, first of all, the graph looks like a parabola. And as we approach the right side, it's also positive infinity. But if it's negative, then we are still a positive function in all, so it's still opening up. And this time we're going to the left, and that is also positive infinity. Now what about if it's odd? So if it's odd and it's positive, it's essentially the same type of situation, sort of. So it's a line though this time, and positive infinity is to the right. So this is positive infinity because it's up. But then when you approach negative infinity of the same picture, that is going to be to the left, and being to the left is negative infinity. Now what happens when it's a negative function instead of a positive function? Essentially, it's flipped upside down, so the idea of where it's approaching also flips upside down with air quotes. You can't see that though. So let's switch up the color. Boom. Our parabola is upside down with negative coefficients, but as we approach to the right, we are hitting negative infinity since it's going down. And as we approach to the left, we are also hitting negative infinity because it's going down. For our odd degree function, it's going to be the opposite way. So this time the function is going down. And as we approach positive infinity to the right, it is down. So it's negative infinity. And as we approach negative infinity to the left, this is positive infinity. So notice how everything just literally flip-flopped. The picture flip-flopped upside down, and what you approach, your limits, your end behavior, flip-flopped as well. All right. That's our end behavior. So let's do this thing without a calculator. A few more things you got to know, though. So zeros and extrema. Zeros, you know what zeros are. Those are the x-intercepts. Let's recall that, though. The zeros are the degree, literally the exact number of the degree. The extrema, which is, so let me go ahead and just write that as a recall. Zeros, remember, are x-intercepts. X-intercepts. And the possible extrema, remember, those are the maximum or minimum. And it's technically the maximum and minimum. But the number of x-intercepts is the degree number exactly. The number of possible extrema, which is the maximum and minimums, is the degree minus 1. Okay. Example. State the number of zeros, which is the degree. State the possible extrema, which is 1 less than the degree. And the end behavior without a calculator. Here's our example. Okay, stating the number of the degree. First of all, we need to identify the degree. So this is a 5 degree. So since our degree is 5, and technically this thing is opening down, well, it's going down, it's odd. So odd means it's going to be a line going down. So let's keep that in mind as we fill in our zeros. The zeros, how many zeros are there? Oh, wait, what does it say? Oh, it's the degree. So there are 5. The possible extrema. Well, how many extrema can you have again? Oh, it's the degree minus 1, so it's 4. And then the end behavior, I'm going to abbreviate that EB, is the limit of y as x approach infinity. And what is happening as x approach infinity, just take a look at your little sketch you drew. Oh, it's going to negative infinity. So that is negative infinity. And then the limit of y as x approach negative infinity, well, again, look at your little sketch you drew. It's going to the left, so, and it's up. So that's positive infinity. And that is our picture. Or that is the answer. And we didn't need a calculator. Go us, go us. Let's do example number 2. Same type of situation. We need to first identify the degree and if it's even or odd and what the actual picture should look like. So our degree is 4. This is even. And so even is a parabola, but it's a parabola opening up since it's positive. And now we can answer all the questions. The zeros, there are 4 of them. The possible extrema, there are 3 of them, because it's always 1 less. And the end behavior is the limit of y as x approach infinity. And that's infinity to the, I don't want that color, this one. Infinity to the right is positive infinity. And the limit of y as x approach negative infinity is, well, negative infinity is to the left, and that is also going up. So that is infinity. And that is all that we want. Ta-da! All right, guys, we're almost there. Almost there. Last couple things. Factors and multiplicity. Factors and multiplicity. So again, recall that zeros are also known as roots, solutions, and x-intercepts. Now we have this k thing. And k is going to be a 0. And remember, 0 is nothing but a root, a solution, or x-intercept. So our k is our x-intercept of a polynomial. X minus k is a factor, is our solution, or x equals k. And it's the solution to make the actual problem equal 0. And then if k is a real number, then k is an x-intercept. All right. Next thing, if x minus k has an m exponent thing going on. So m is the multiplicity of the 0k, which is nothing but how many times x minus k is in the factorization. So like I could have x plus 3 times x minus 5 times x minus 5. Well, instead of having the x minus 5 situation, I would have x minus 3, or x plus 3, excuse me, times x minus 5 squared. That's all that's saying. I have x minus 5 2 times because our m, our little exponent, is 2. Okay? Next is, it also tells you how many times k is at 0, and it's repeating itself. So in this particular case up at the top, since you have 2 5s, then that means you have k as equaling 5 2 times. There's a way to show that too, and here is how you show it. If m is even, your picture will bounce, and so that'll show that you're going to bounce on that number, and so essentially it means it's happening multiple times. So it's going to bounce on it, and it's showing that it's even, and again, yeah, happening multiple times. So if we have k, it will bounce. And just think about it, x squared, doesn't that look like something that this looks like? A parabola. And it has an even exponent, and it's bouncing. It's going to end up bouncing, especially if you have one x-intercept. That one x-intercept is going to be an x-intercept 2 times. Why? Because our zeros or x-intercepts is the amount of the degree. And if the degree is 2, you have 2 x-intercepts. But if it's odd, it's going to go through. And so an odd function that you can probably think of is cubic. If this is our k, our cubic could look something like this. And it's going through. So you end up having k equal 1 time. All right. Or k equal an x-intercept 1 time. Okay. Steps to graph without a calculator. Okay, let's do that before we do the examples. Step 1, you must be in factored form. So it must have, for example, like this x plus 3 times x minus 5 squared. That is factored form. It must be in factored form. Okay? Step 2. You are going to graph the zeros in x-intercepts / x-intercepts, but it has to have their multiplicity. So if it's even, it's got to bounce. If it's odd, it's got to go through. Step 3, you're going to graph the y-intercept, so you just plug in x equals 0 to figure out what that even is. Step 4 is you're going to evaluate more points if necessary to find the end behavior. And that is all the steps. So now let's officially do an example. State the zeros, y-intercept, and end behavior, then graph. Here is our function. We're not using a calculator at all. Here is my graph. I want you to make sure you pull this out on your graph paper. And let's begin. So following the steps, let's see what the first step was. Must be in factored form. Check. Step 2, you gotta put down the zeros, the x-intercepts. What in the world are they and their multiplicity? So our zeros are, well, it's based on the degree. So let's see what the degree is. We have a 2. This right here has no power at all. That's a 1. And the power of the 1/6 doesn't matter because it's always the degree of the variable. So we're looking at the sections that have a variable. So if you were to multiply this all out, this would end up being x to the 3rd power, and that is your degree. And so since it has a degree of 3, then that means you're going to have 3 zeros. And so your 3 zeros technically are going to be x equals -3. But don't forget the multiplicity. With a multiplicity of 1, and x equals -2 with a multiplicity of 2. But remember, you got to have 3 zeros in all. I only see technically like 2 zeros. Oh, but what you got to realize is that this is 3 zeros because this equals 3 zeros in all. It's just one thing is going to bounce and one thing is going to go through. So let's see which one is going to bounce because you got to make sure you remember that part too. So since that is odd, you're going to go through. And since this is even, this is going to bounce. And that'll help us create the shape of our function. All right, next, let's do the extrema. Extrema wasn't one of the steps, but I like to do extrema just so I can know like what kind of picture I'm looking for in terms of the maximums and minimums. So since our extrema is 1 less than degree, we should have two extremas. So next is the y-intercept. And for the y-intercept, again, all you have to do is plug in 0. Plug in x equals 0. So this is 1/6 times 0. Oh, let's go ahead and make that a different color. Plus 3 times something plus 2 to the second power. And so we're going to make it pop. Pop. Bam. So type that all into your calculator. And you end up getting that this equals dun, 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 2. Very simple. So our final answer is 0, 2. All right. Next thing to do, and the very last thing to do, is your end behavior. Now remember, the end behavior of this should go off of the degree. The degree. All right, so since our degree is 3, then that means our picture is going to be a line, and it's a positive 3, so it's a line going up. And so since we have a line going up, now we can do our end behavior. This is the limit of f of x as x approach infinity equals, and let's see what happens as we approach infinity. That's to the right. That is, infinity. And then the limit of f of x as x approach negative infinity is, okay, let's see, going to the left, negative infinity. Oh, that is also negative infinity. And so this will help us create our picture. Okay, so let's plot some important dots. Dot number 1, we need our zeros, our x's. X equals -3, x equals -2. But we then need to make sure we go through and we bounce. We also need our y-intercept, and we need to make sure our end behavior matches as well. Again, your extrema is extra. Like, you really don't need that part, but it just helps to let you know, like, okay, I should have 2 humps going on in this picture. Just 2 humps. So I'm going to just add that right here. 2 humps. Okay, so let's plot the dots. So we have x equals -3, so we go to -3 and put a dot. X equals -2, go to -2 and put a dot. I believe this should be +2 because -2 doesn't make sense. Okay, so we're going to edit this right quick. I'm going to make this be -2 right there so that our number we actually get is a +2, so it can go to the other side of the y-axis, because then it's just mushed together and it's going to be looking really weird. Okay, and this ends up equaling, let's make sure that this is working. Yeah, it still ends up equaling 2. Okay, because I'm sure you were like, wait, that didn't equal 2 to begin with. No, it didn't, but now it does. And so this is x equals 2. Now we want to point at 0, 2. 0, 2 is up here. And yeah, that is it. Now we need to identify what's happening. What are we doing at -3? We're going through. What are we doing at +2? We're going to bounce. So we just need to make sure our end behavior is a match as well. So our end behavior has to look, again, like this. So we're going to come from the left and go up. So I'm just going to take it from way down here. Let's make it a little straighter. Way down here and going up. Okay, it's got to go through. Okay, I didn't want to make that straight. So it's got to go through. So it goes through. Then it's got to go directly to the next thing. Then here it's going to bounce. And so that means it's going to go back up. And ta-da! You have successfully drawn this function without a calculator. And it indeed follows the overall general common graph of a cubic odd positive function. All right, this concludes my video notes. Please make sure that if you need to, go back, look at it, pause it as needed. Make sure you have the notes written down, and you will practice this next class. Hopefully you understood. Make sure you ask your teacher questions if you don't. I will see y'all in another video. Marshall, out.